In this video, we're going to learn how to use logarithmic properties to solve an equation. Now, we learned in the last lesson that if we have a single logarithm, we can rewrite it in exponential form, but here you see two logarithmic expressions. Now, we learned a few properties to combine these into a single logarithm, so that's what I'm going to do. If you're ever adding two logs, they can combine with multiplication within the log, giving me x minus 3 times x within just one of the logs. Now when we do x times x minus 3, you get log of x squared minus 3x. And then we'll rewrite this because now it's a single logarithm. So we'll rewrite this in exponential form. Now this log is understood to be base 10. So we can rewrite this as x squared minus 3x is equal to 10 to the first power, which is just 10. Then we can subtract it to the left side, give me x squared minus 3x minus 10 equals 0. And now we just have a quadratic that needs to be factored in order to solve this problem. X squared minus 3x minus 10 factors into x minus 5 times x plus 2. Setting both of those factors equal to 0 using the zero product property. We get x is equal to 5 and x is equal to negative 2. Now when we go back and check, if we could plug in 5 because we get log of 2 times plus log of 5, which should equal 1. If I plug that in. Log of 2 plus log of 5 is 1. But when I go to plug in negative 2, I get log of negative 5 plus log of negative 2, which logs can't have negatives within them because that's a domain restriction. So negative 2 will not be a solution. That's an extraneous solution. So our only solution is 5. X cannot equal negative 2. Now look at this next problem. We have subtraction between the logs. So when you subtract, instead of multiplying on the inside, subtraction leads to division within a log. So we get log of 6 divided by 3x is equal to negative 2. Log is understood to be base 10, so when I rewrite this in exponential form, I'll have 6 over 3x is equal to 10 to the negative 2. 10 to the negative 2 can be rewritten as 1 over 10 squared. The negative exponent can move to the denominator, and 10 squared is 100. So you have 6 over 3x is equal to 1 over 100. And then we can cross multiply and solve. So we'll have 3x times 1, which is 3x, is equal to 6 times 100, which is 600. Divide each side by 3, and we get x is equal to 200. Now we can check to make sure this is correct. So we'll have log of 6 minus log of 3 times 200, which is 600. That should equal negative 2, and it certainly does. So x equals 200 does work. And another way that as long as we did the math correctly leading up to it, this should work as long as it creates a positive number within those logarithms. Next up, we have logs on either side of the equation. So in order to solve this, you might think, oh yeah, 7x plus 1 just equals x minus 2, but there is this additional plus 1, which is throwing that path to solving off track. So what we need to do instead is move everything to one side of the equation by subtracting log base 4 of x minus 2. Leave me with log base 4 of 7x plus 1 minus log base 4 of x minus 2. And that's just equal to 1. Keep the 1 by itself on the right side. And we'll combine all the other logs together. So when this combines, it is with subtraction, so we're going to divide like in the previous problem. So log base 4 of 7x plus 1 divided by x minus 2. And then we'll rewrite this in exponential form. So this will be 7x plus 1 over x minus 2 equals 4 to the first power, which is just 4. And over here, just so I can solve this equation, I need to multiply each side of my equation by x minus 2 to get that out of the denominator. Leaving me with 7x plus 1 is equal to 4x minus 8. And then I can subtract 4x, which gives me 3x plus 1 equals negative 8. Subtract 1, so we get 3x equals negative 9. And then x equals negative 3. Now, one thing to look out for here is that negative 3 would make this log negative and that log negative. That would be negative 21 plus 1, which is negative 20. And log base 4 of negative 3 minus 2, which is negative 5. So since it makes both those logs negative on the inside, that x cannot equal negative 3. So in this case, there is no solution. You usually see these extraneous solutions pop up when we start using these properties to solve. And we do need to use the properties, else we couldn't solve them. Next up, I have 2 log base 3 of x plus log base 3 of 4 is equal to 2. So I want to combine both these logs, but I do have a coefficient in front of that first log. So in order to get rid of that coefficient, I'll move it inside the logarithm. Give me log base 3 of x squared. It becomes a power on the inside. Plus log base 3 of 4 equals 2. Now they're being added, so just like in the first example, I can combine this into one logarithm. Log base 3 of x squared times 4. So I have log base 3 of 4x squared equals 2, and now it's set up for me to switch to my exponential form like I have in the previous problems. Giving me 4x squared is equal to 3 squared, which is 9. Then I'll divide by 4, give me x squared equals 9/4. I'll then take the square root of each side of my equation. On the left, I'll have the absolute value of x, and on the right, the square root of 9 is 3, the square root of 4 is 2, 3/2. And then to finish solving, to get rid of the absolute value, I'll take the plus and minus of the right side, so x is equal to plus or minus 3/2. So between these two solutions, checking the first one, that leaves me with a positive value inside that logarithm, so it should be a solution. But the second one would leave a negative within that first logarithm because you have 2 log base 3 of negative 3/2, and you can't put a negative within a logarithm or else it's undefined. So x cannot equal the second solution. And that is how you use logarithmic properties to solve equations.